Hello, my name is Rüdiger Löckenhoff and I'm presenting to you the Open CPV Solar Tracker Controller. It's based on a magnetic compass and it has been sitting in the garden shed for the whole winter now. And I'm quite happy to see that the magnetic compass is still calibrated as I started it up now. It is in the cleaning position right now, where it would be easy to clean, and I tell it to go to astronomical tracking now. You can see it moves. It has one driven wheel here. It is a 3-wheel cart and it has a winch which will pull up the generator now. And well, it's tracking my compass right now, but it will try to find the sun if we had sunlight. Not too much sunlight right now. Thank you. Now it's moving. Okay, and now it's on astronomical tracking. The sunlight is not strong enough. So now this is another interesting feature about this winch. The wire is wrapped around the winch here, and there may be a situation when there's a storm, but the electricity is also gone because maybe the mast has fallen down. And what will happen now, when the wind is shaking the generator, it will actually move to the zenith position, which is the stow position with least chance of attack of the wind against the generator. This is the typical stow position and it's a passive safety feature. You may be surprised to find that I'm actually using rocks here as a counterweight, but that is a realistic case because when you are installing in the desert with rocks available, you wouldn't want to use something expensive like steel as a weight, but you are using what you are having. And I would even suggest to put extra load on the tracker here, also from pebbles or rocks which are readily available and cheap, and will make sure that the tracker cannot fall over in the wind. This is the controller box now. You can see that there are LEDs which are used as photodiodes and the shading beam. Unfortunately, we don't have enough sun right now. Here there's the communication port, and there are the ports for the azimuth and elevation motor, and here the 24 volts DC power are coming in. Those CPV modules are the Flatcon modules, and they are a courtesy given on loan by the Fraunhofer Institute for Solar Energy Systems in Freiburg, Ise. And I thank them a lot for them to allow me to build up a realistic CPV solar tracker. This is the driven wheel taken from a set with a wheel and a gear motor that is used for robotic applications. The tracker structure is made from wood. I wouldn't really do that for outdoor applications. It will be rather made from steel and maybe concrete. But the construction may be very similar. The communication port is either for serial communication with the computer, or in normal operation it will be connected to a wind sensor. Here a pull string interrupter will go that will interrupt the azimuth motor when the tracker is turning too far and cables would rip otherwise. When we need this box really waterproof, we will put a silicone sealing along here. And I didn't do that yet because I wasn't sure that I wouldn't need to open it again. On the back side you can see the breathing tube. I wouldn't want the box to become leaky in an unexpected position where it might suck in water, so we have a breathing pipe that always faces down, and which is a controlled way of breathing when the air pressure or the temperature of the box are changing. We do have sun now, and I can show you how it works. If I'm covering part of the sensor, then this tracker will move. And if I let the sunlight come on it again, with a few steps, it's completely back on sun. Now this is the serial interface. Up here you can see the sensor readings when it has actually tracked by sensor. And down here you can see a printout of all the parameters which are stored in the EEPROM and which are used to change the behavior of the solar tracker. Change the motor speed, soft start, soft stop, positions like leaning position and so on. This is the new all-in-one control board, and you can see that I still connected a breakout board with an MPU 9250 compass here, because we still had some issues with the sensors, which are mostly settled now, and there's space for the sun sensor here. And this board is capable of switching 400 watts, so it's usable for pretty big trackers. It has an real-time clock and everything that you need. Also RS485 communication, by the way.